Someone asked Google's most advanced quantum-powered AI system a question that philosophers, theologians, and physicists have been asking since human beings first looked up at the night sky and wondered, who built the universe? Not how did the universe begin, not what are the physical laws that govern it. Who? The response that came back was not the deflection that most people expected. It was not a polite redirect toward religious tradition or a disclaimer about the limits of machine knowledge. It was something far more unsettling than either of those safe answers. Because when you take the full power of a system trained on the complete body of human scientific knowledge, integrated with the quantum computational capabilities that Google has been developing for years at the absolute frontier of what computing can do, and you ask it the oldest question in human history, what you get back is not an answer. What you get back is a precise and unflinching map of exactly why the question is harder than anyone who has not thought about it seriously has ever imagined. And that map, drawn with the tools of modern physics, quantum mechanics, cosmology, and information theory, leads somewhere that the scientists who built those tools are still standing at the edge of staring into without being able to see the bottom. To understand why the response was unexpected, you first need to understand what most people anticipate when they ask a powerful AI system a question that touches on religion, metaphysics, or ultimate origins. The standard expectation is one of two things. Either the system deflects entirely, offering a neutral summary of what different religious and philosophical traditions believe without committing to any position of its own, or it gives a confident, reductive scientific answer, something along the lines of, the universe was not built by anyone. It emerged from a quantum fluctuation in a pre-existing vacuum. End of discussion. Both of these responses are comfortable in their own ways. The first respects the question's religious dimensions without engaging them. The second dismisses the question's depth by treating it as already resolved by physics. Neither one requires sitting with the genuine, unresolved strangeness of what the evidence actually says when you follow it all the way to the end. What Google's quantum-integrated AI systems actually produce when pressed on questions of ultimate origin reflects the full weight of what modern physics has established, and crucially, what it has not. The starting point is always the same: the Big Bang. The moment approximately 13.8 billion years ago when the observable universe emerged from an extraordinarily hot, dense state and began expanding. This is not contested. The evidence for it from the cosmic microwave background radiation that fills the sky in every direction to the observed recession of galaxies to the abundance of light elements produced in the first minutes of cosmic history is so comprehensive and mutually consistent that no serious cosmologist disputes the basic picture. The universe had a beginning. Everything we can observe, every galaxy, every star, every atom, every photon of light, emerged from a state of almost incomprehensible density and temperature approximately 13.8 billion years ago. But here is where the response turns unexpected. Because the question of who or what caused that beginning is not answered by the Big Bang, it is sharpened by it. The Big Bang describes what happened. It does not describe why it happened, what existed before it, or what kind of entity or process or principle could account for the existence of the conditions that made it possible. And when Google's AI systems engage with this question at full depth, drawing on the quantum cosmology literature, the information theoretic approaches to fundamental physics, and the mathematical frameworks of string theory and loop quantum gravity, what emerges is not a tidy explanation. It is a layered series of questions, each one deeper than the last, each one pointing toward a foundation that the current edifice of physics has not yet reached. The first layer involves what physicists call the fine-tuning problem, and it is the element of the universe's structure that produces the most discomfort among physicists who think about it carefully. The universe is governed by a set of physical constants, numbers that determine the strength of the fundamental forces, the masses of elementary particles, and the energy density of the vacuum, the gravitational constant, the speed of light, the fine structure constant that governs electromagnetism, the strong nuclear force coupling constant, the cosmological constant that governs the rate of the universe's expansion. These numbers are what they are, and the universe we observe is the result. But here is what makes them so difficult to sit with comfortably. If any of these constants were even slightly different from their actual values, the universe we observe, with its stars, its planets, its chemistry, its biology, its conscious observers, could not exist, not different in some large dramatic way, different by fractions of a percent, in some cases by far smaller margins than that. If the strong nuclear force were slightly weaker, atomic nuclei could not hold together and there would be no chemistry. If the cosmological constant, the energy of empty space that drives the universe's accelerating expansion, were even slightly larger than it is, the universe would have expanded too fast for matter to clump into galaxies and stars before it was diluted to nothing. The actual value of the cosmological constant is so extraordinarily small compared to What quantum field theory predicts it should be that physicists call the discrepancy the worst prediction in the history of physics. It is off by a factor of 10 to the 120, one followed by 120 zeros. The value we observe is so much smaller than the value the theory predicts that no mechanism currently known to physics can explain the difference. And yet, it has exactly the value that allows the universe to expand at the rate that permits galaxies to form, stars to ignite, planets to condense, and the process that eventually produces conscious beings to proceed. A number off by a factor of 10 to the 120, yet somehow landing precisely where it needs to be for anything at all to exist. When Google's quantum AI is asked to engage with this problem honestly, the response does not reach for easy explanations. The three frameworks that modern physics offers to account for fine-tuning are each deeply unsatisfying in their own specific way, and a system trained on the full literature cannot hide that dissatisfaction behind confident simplification. The first framework is the anthropic principle, which argues that we should not be surprised to find ourselves in a universe compatible with our existence, because we could not exist in a universe that was not compatible with our existence. This is logically valid and physically empty. It explains why we observe fine-tuning without explaining how the fine-tuning came to be. It answers a question nobody was asking while leaving the actual question entirely untouched. The second framework is the multiverse, the proposal that our universe is one of an enormous or infinite number of universes, each with different values of the physical constants, and that we find ourselves in one with life-permitting constants, simply because those are the only ones where anyone could be around to notice. The multiverse is a serious scientific proposal, arising naturally from the mathematics of cosmic inflation and string theory's landscape of possible vacuum states. It is also, by construction, unverifiable with any currently conceivable instrument. The other universes, if they exist, are causally disconnected from ours. We cannot observe them, cannot probe them, cannot design an experiment that would tell us whether they are real or whether the multiverse is a mathematically convenient fiction that our theories generate without any corresponding physical reality. Google's quantum AI, when engaging with this framework honestly, produces something that the scientists who developed it find genuinely uncomfortable to hear, stated plainly. The multiverse explains fine-tuning at the cost of making the explanation permanently untestable. It substitutes one profound mystery for another, trading the question of why our universe has these constants for the question of why a multiverse generating all possible constants exists at all. The third framework is the one that the question of who built the universe is most directly asking about, and it is the framework that the AI response treats most carefully. The possibility that the constants are what they are because they were chosen, because an intelligence of some kind, operating at a level of reality prior to or outside of the physical universe we observe, selected or implemented the values that make conscious life possible. This is the framework that most people calling themselves religious or theistic would recognize as their own, and it is also the framework that several serious physicists and philosophers of physics have argued cannot be dismissed on purely scientific grounds, not because science has found evidence for it, but because the nature of the fine-tuning problem is such that science alone may not be equipped to resolve it. The Nobel Prize-winning physicist Eugene Wigner wrote about what he called the unreasonable effectiveness of mathematics in the natural sciences, the mysterious fact that mathematical structures developed by human minds for purely abstract reasons turn out to describe physical reality with extraordinary precision. The equations of quantum mechanics, developed in the 1920s from abstract mathematical principles, predicted the properties of elementary particles to more decimal places of accuracy than any other theory in the history of science. The geometry that Einstein used to describe gravity was developed by Bernhard Riemann decades before Einstein was born, with no physical application in mind. Why does mathematics describe nature so well? Why does the universe have mathematical structure at all? Why is there something rather than nothing? And why does that something obey equations that a mind can write down and solve? These questions sit at the boundary between physics and philosophy. And they are questions that Google's quantum AI, when asked about the builder of the universe, places squarely on the table without pretending they have been answered. The quantum mechanical layer of the response is where things become genuinely strange at a technical level that most popular accounts of cosmology avoid because it is so difficult to convey without the mathematics. Quantum mechanics, the theory that governs the behavior of matter and energy at the smallest scales, is the most precisely tested theory in the history of science, and it contains, at its foundation, a feature that nobody fully understands and nobody can explain away: the measurement problem. In quantum mechanics, a physical system exists in a superposition of all possible states until it is measured, at which point it appears to instantaneously collapse into a single definite state. What constitutes a measurement? What causes the collapse? Why observation should have any role in determining the physical state of reality? These are not questions at the frontier of the theory. They are questions about the theory's foundations that physicists have been arguing about since the 1920s without reaching consensus. Some interpretations of quantum mechanics, including the Copenhagen interpretation developed by Niels Bohr and his collaborators, treat the collapse of the wave function as a fundamental feature of reality that requires an observer, but decline to say what an observer is. Other interpretations, including the many worlds interpretation, deny that collapse happens at all and instead propose that every quantum measurement causes the universe to split into branches, each containing a different outcome. Still other interpretations, including various objective collapse theories and pilot wave theories, attempt to restore a more classical picture of physical reality at the cost of other theoretical prices. None of these interpretations has been experimentally distinguished from the others. They all make the same predictions for every measurement that has ever been performed. They disagree not about what happens, but about what it means. And some of the things they mean, particularly in the realm of what role observation and information play in constituting physical reality, carry implications that are deeply relevant to the question of who or what built the universe. John Wheeler, one of the 20th century's most influential physicists, and the man who coined the terms black hole and quantum foam, spent the later decades of his career arguing that the universe is fundamentally participatory, that information and observation are not byproducts of a physical reality that exists independently of them, but are in some deep sense constitutive of it. His It, from Bit Proposal, suggested that every element of physical reality derives its existence from yes or no questions, from binary choices, from information in the most fundamental sense. This is not mysticism. It is a serious proposal from one of the serious physicists of the 20th century, and it points toward a picture of the universe in which the boundary between the observer and the observed, between the mind and the physical world, is far less clear than the everyday picture of reality implies. When Google's quantum AI integrates these threads, the fine-tuning problem, the unreasonable effectiveness of mathematics, the measurement problem in quantum mechanics, Wheeler's participatory universe, the limits of the multiverse as an explanation, and the hard problem of consciousness that asks why any physical process should give rise to subjective experience at all, what it produces is not an answer to who built the universe. It produces a precise characterization of why the question is harder than physics alone can currently resolve, combined with an honest acknowledgement that the frameworks available to answer it remain either untestable, incomplete, or both. The response is unexpected because people asking the question typically want one of two outcomes: either a confident scientific answer that closes the question by explaining it away, or a deferential acknowledgement that science cannot speak to matters of ultimate meaning. What the AI actually delivers is neither. It delivers the full weight of what the most sophisticated scientific and philosophical thinking humanity has produced says about the question, which is that the universe displays properties, its mathematical structure, its fine-tuned constants, its quantum mechanical foundations, its apparent requirement for observers to fully constitute physical reality, that are genuinely strange in ways that neither confident atheistic materialism nor simple theistic creation fully accounts for. The universe is too specifically structured for conscious life to exist, and the structure is too mathematically precise and too deeply ordered for the question of whether intelligence of some kind is implicated in its existence to be dismissed as superstition. It is also too different, in every way that matters, from anything a human builder would build using human methods for the concept of construction to apply to it in any familiar sense. What Google's quantum AI reveals when asked who built the universe is the precise shape of a question that sits beyond the current reach of human knowledge, not a gap in knowledge that will be filled by the next experiment or the next theoretical breakthrough. A structural feature of the question itself that requires tools, conceptual frameworks, and possibly modes of understanding that do not yet exist. The response is unexpected because the most sophisticated intelligence humanity has built, trained on everything humanity knows, reaches the edge of that knowledge and stops. Not with a comfortable answer, not with a deflection, with a map of the territory beyond the edge, drawn as carefully and honestly as the knowledge that produced it allows. And at the center of that map, where the answer to the oldest question in human history should be, there's a space that no equation, no observation, no quantum computer, and no artificial intelligence has yet been able to fill. The universe exists. It is extraordinarily specific in its properties. It produces minds capable of asking why it exists. And the question of whether that specificity, that productivity, that precise mathematical elegance that makes both physics and life possible, points toward something beyond itself is one that the most powerful thinking machines humanity has ever built arrive at the edge of and then, with all the honesty that genuine intelligence requires, simply stop. Not because the question does not matter, because the question matters more than any answer currently available is large enough to hold.